Okay, welcome to 10.7. Okay, I'm going to explain figure 3. Um, Here is what's going on when Kurt creates figure 3. So now, first, what we're going to do, um, uh, let's see, I think. Um, okay, wait, I'll talk about the parameters in just a second. But now, just assume instead of generating data, we're going to assume particular values for the independent variables. So, in particular, what he does is assume m2 equals, no, 20. M2 equals 20, okay? A1 equals A2 equals 40. And then D12, whether there's a democratic piece or not, whether they're democracies or not, is 0. So at least one of them is not a democracy. And then M1 varies from 0 to 100. Okay. Now, I think I got this right. Then for both cases, so remember, he looks at what he calls the strategic model, and that's his structural model. So, like us assuming the correct way to do this. Um, and then he also looks at what he calls the naive model. I called it, sorry again for the PG language, the rat shit logit, okay, where you just throw everything in. Dependent variables is 0 or 1, whether you go to war or not. Okay, you run a logit. All right. Now, um, you learn this in other econometrics classes. So suppose you run your model. Suppose you run your logit model. You got your estimates from table 1. Okay. Once you plug in, remember your dependent variables, whether you go to war or not, 1 or 0. So the logit estimates for a given set of independent variables, and if you know all the estimated parameters, you can calculate the probability of going to war given those parameters. All right. So what Kurt is going to do is going to set 4 of the independent variables, or 5, I guess. No. 4 to particular values: 20, 40, 0. Okay. And then he's just going to say, all right, now we're going to calculate it once where M1 equals 0. Okay. Calculate the probability of going to war given the logit estimates. Try it again when M1 equals 0.5. Try it again when M1 equals 1, so on. Okay. And then what he's going to eventually do is get a graph of the probability of going to war that the logit technique predicts. Okay, let me show you that right now. That's what he does in figure 3. And that is, okay, so we're in figure 3. That's just the dotted line. Okay, notice that, sorry. So the dotted line here goes, starts off high when, so when M1, country 1, has 0 military assets, the probability of war is high. But as country 1 gets more and more military assets, the probability of war starts going to getting very small. Okay. By the way, this is so you're not old enough to remember during the Reagan years. Reagan talked about peace through strength. Okay, this is the way we're going to have peace: is to have the U.S. be very strong militarily. Now, I think Reagan, in fairness to Reagan, he was saying you get peace when you have a good country, a good country that doesn't want to go to war, that doesn't want to colonize other countries and take over the country. When that country is very strong, that's when you get peace. Now, in Signorino's model, you don't assume that there's countries are good. They are attacking each other if it benefits them. Okay, but nevertheless, that Logit model, that's what it showed. It showed even in that case, when M1, the stronger it got, the more likely you were to have peace, or the lower the probability of war. Okay, but now the next thing is Kurt does the same thing for his strategic model. So he says, okay, we've got the betas. Now, I don't know if he used beta equal 1 or actually used the, I think what he did is he used the 0.98, 0.99 that his estimates that he got in table 1, but regardless, they're about the same. So use those estimates, and then you can calculate. And if you've got, all the values of your independent variables, those estimates, you can calculate all the P1s, Q2s, Q3, P4. If you've got those values, you can say, what's the probability of W1? Well, it's P1 times Q3. What's the probability of W2? Well, it's 1 minus P1 times Q2 times P4. So actually, those two cases of war, you add those probabilities up, and you get the probability of war. Okay. Then 1 minus that's probability of peace. You do that again when M1 equals 0.5. Calculate all the P's, get your probability of war, probability of peace. Do it again when you set M1 equal to 1 or 1.5 or 2. You keep on doing that, and you keep on calculating probability of war, probability of peace, and you can create the second graph. And this is here, figure 3, and that is the solid line. Okay, notice that looks like kind of a double humps. And so notice, okay, recall that the other country, so this is a function of the horizontal axis is M1, how much the first country, the military assets of the first country. So when country 1, actually when it has 0 assets, you can't see it on this graph, but actually the probability of war is very low, and it's because that first line, that line there, actually has a very steep slope. It's almost 1. Okay, but then all of a sudden when country 1, and now the reason the probability of war is low because country 1 capitulates. When it has 0 assets, it realizes, like, we can't win a war. We got to capitulate. Country 2 says, oh, we can invade pretty easily. So, let's invade. The other country capitulates. Then all of a sudden, though, when country 1 starts getting its military assets, it gets up to something like 2 or 3 or 5. I think what happens is it doesn't capitulate as much. But the first country realizes, we got 20. Remember, the second country, M2 is 20. Is that right? Yeah, M2 is 20. It says, okay, we got 20. We can invade and win. Okay, so they start invading. If country 1 has a few assets, they won't capitulate. They have war. But notice right here, when M1 is very close to 20, that's when they both have about the same number of military assets. They realize, it's not clear we're going to win. So both countries realize that, so they don't invade. So you get peace when both countries have about 20, but then all of a sudden, remember, M2 stays at 20. If M1 starts getting more and more, M1 starts getting bolder, their country 1, and it starts invading. Country 2 says, well, it's, they've got more military assets than we have, but not that much more. Maybe we'll fight. But then when all of a sudden country 1 starts getting like 100 on its military assets. It has much, much more. Remember, country 2 has 20. So it has 5 times the military assets of the other one. It can threaten war, but then the other country just capitulates. And so that's when you get peace again. So you get regions of peace when M1 is near 20, and also when M1 is very, very high. But notice that it is nothing like a linear relationship. You have this double hump relationship. And so in this logit case, it's going to have, it's not quite linear, but it's, the relationship is going to be monotonic in the military assets of one, and that's why that dotted line is a little more smoothly shaped. It's not double hump. But remember, in this case, the truth is the double hump shape, and the point is that Kurt is demonstrating, if you start doing a logit, if you don't have the right structural model, you're really not going to approximate the truth very well at all. The truth is a double hump, and that, that dotted line from the logit is not, in my view, approximating that double hump shape very well. Okay. Final figure 4, I guess that's just the logit case where you do that. You add that ad hoc independent variable, their military concentration, how close each country is to having half of the military assets, how close they are to being even. And that was the fraction of country one's military assets minus 0.5, and you take the absolute value of that. So, figure 2, it does a little bit better of approximating that double hump shape, but not that much better. Okay. So that's it. That is the Signorino paper, or what I wanted you to learn of it. And I wanted you to see that figure 3. That's the important part. That's what impressed everyone and helped Kurt be a star on the job market and make a great contribution to international relations research. The final thing, so I told you don't worry about reading the latter sections of that paper, where Kurt actually gets some real data. So far what I've done is just used what happens when you have simulated data. Kurt actually gets some real data. Now it is so taxing to go through that. So he gets some real data. What he does is he gets the data from a previous published paper. That previous published paper had like a pretty complicated game, and then Kurt redoes a structural model for that new extra complicated game. It is so complicated. It is just so taxing trying to slog through that. I don't want you to have to do that. The key is just to see that figure 3. Except the final thing I want you to notice from that, and this is some speculation, but the data he gets is from a paper by Bruce Bueno de Mesquita and 1 or 2 other authors. I highly suspect that Bruce Bueno de Mesquita was a referee on this, and the reason this was published was because of Bruce Bueno de Mesquita. And I want to give a compliment, if I'm right, to Bruce Bueno de Mesquita. And I've met him, know him. He's a great guy and a great scholar. What often happens in situations like this, so Bruce Bueno de Mesquita is the highly respected, famous scholar. Kurt Signorino has done this technique that says, look, this is an improvement. I'm improving what Bueno de Mesquita and his co-authors have done. Often you get scholars who are petty and saying, no, it's not an improvement. Here's the wrong assumptions, and no, reject it. and I'm speculation, but I think I have a hunch. One, Bruce Bueno de Mesquita gave his data to Kurt, so I know that he's very generous with the data. But I also think that he was a referee, and I suspect, looks like said, publish it. Yeah, okay, he did make an improvement on my paper. It deserves to be published, and that's very noble. If I'm right, that's very noble what Bruce Bueno de Mesquita did, and happen to know him. That's consistent with his character, and that's partly why I'm speculating that that's what happened. So the final point, I think that I think Kurt was lucky to have such a great person, uh, noble and with a little bit of modesty, Bruce Bueno de Mesquita, who I suspect might have been instrumental for this paper getting published. Okay. Oh, and the final thing. Oh, anyone who's watching. So in the COVID era, everyone's watching Netflix. If you're on Netflix, it was one of the trending series, How to Be a Tyrant, something like that. It's, I think, 6 episodes, and they interview some scholars to talk about how Hitler and Kim Jong Il and these other Stalin, what they've done to be good at being a tyrant. Now that means evil, but Bruce Bueno de Mesquita is interviewed, and so if you want to see what he looks like, what he sounds like, watch that series. You'll see. So okay, that's the final point. We've finished. Kurt Signorino's paper, the key thing, we've talked about structural models. Most of this course, it's just been decision theoretic models. And then we got into McKelvey-Palfrey, game theoretic models. And then an extension of that, Kurt Signorino's model, where it extends, in my view, the McKelvey-Palfrey papers. So we've done that. The next session I'm going to do a paper I wrote with Crable, and it's all from techniques I learned from taking Jonathan Feinstein's course. And I think I told you earlier, Jonathan Feinstein was a student of McFadden. So I kind of consider myself, an academic grandson of McFadden. You all learning from me are academic grandsons and granddaughters of McFadden. But I'm going to talk about a technique from the father, the person in between McFadden and me, and this is Jonathan Feinstein. He has this excellent technique called detection-controlled estimation. Now, his paper is on the syllabus. I didn't have you read his paper, and the main reason is just because it's harder. Okay, I have done a simpler version of Feinstein's. I think it's easier to understand. Read my paper with Crable, you understand that. Want to go further, read the Feinstein version. But I think first, to get a good idea of what's going on, read my paper. So that paper, my paper, written with Crable, where we have a structural model to try to estimate retirements from Congress. Okay, so I'm going to give you a taste of that, talk about what are some of the key aspects to understand before you start trying to read that paper. Okay, and that will be next in the next session. Okay, see you there.